Hey class, Mr. Houston here, back to talk to you about nothing other than right triangles. Today we're going to be talking about special right triangles and what properties hold true with those special right triangles. The first kind of special right triangle we're going to talk about is a 45-45-90. So we have our 90-degree angle, we have our 45-degree angles. Basically, this holds true for every 45-45-90. The legs are x distance, and then the hypotenuse will always be x times radical 2. So to figure out the hypotenuse, we would just take a leg and multiply times radical 2. On the flip side of that, if we ever want to figure out what a leg length is, all we are going to do is take the hypotenuse, I'm going to abbreviate, and we're going to divide it by radical 2. Okay, so those are two kind of formulas you can kind of hold on to as we start to work with these types of 45-45-90s. Okay, so example number 1, find the length of the hypotenuse in these 45-45-90s. First off, we need to make sure they're a 45-45-90. We have a 90, we have a 45-degree angle. That makes this 45 degrees as well. Remember, we know that the legs of the 45-45-90s are both the same, and the hypotenuse is nothing more than the leg times radical 2. So we will just take 8 times radical 2. Really no simplification we want to do there. I want you to leave it as 8 radical 2. Nope, not 8 radical 8. Let's try 8 radical 2. So that is all you would have to have for that very first one. Now let's say we're taking a look at example B, and they don't tell if it's a 45-45-90. We can tell if the legs are the same, then therefore these have to be 45 degrees. Okay, if the legs are the same, then their adjacent angles are also going to be the same. So remember, to our formula up there, to figure out the hypotenuse, we take a leg times radical 2, so 3 radical 2 times radical 2. Now there is some simplification that can take place here. Radical 2 times radical 2 will equal radical 4. The square root of 4 is 2, so we end up with 3 times 2, which will give us a length of 6. So hopefully this all kind of makes a little bit of sense. Again, we're doing nothing but applying this right here, x for the legs, x times radical 2 for the hypotenuse, and if we need to, we can kind of plug it into the formulas there. Okay, so now we're going to try to find a leg length of a 45-45-90 triangle. So remember, to find a leg, we are going to take the hypotenuse, and we're going to divide it by radical 2. So the hypotenuse in this case is 5 radical 2. So we will take 5 radical 2 over top of radical 2. The nice thing about this is 5 times radical 2, so as long as I have a similar factor in both the numerator and denominator, they will cancel out, and therefore the leg in this case will just simply be equal to 5. So this x would equal 5, and this x would equal 5. Okay? Alright, let's do a little standardized test practice here. They want us to find the length of WX. So WX happens to be the hypotenuse in this case. So if we remember back to our formulas to figure out the hypotenuse, it is just simply a leg times radical 2. Now what they want us to talk about here is that you need to understand that there are some that you can already cross out. We're trying to find the hypotenuse, so the hypotenuse is never going to equal the same thing as one of the legs. Okay, so they want you to already get rid of that, so we're already down to just 3 answers. Okay, hopefully you'll remember that a 45-45-90 is times radical 2. So in this case, to figure out our hypotenuse, we will take 25 times radical 2. There is no simplification that can be done to that, so our final answer is just 25 radical 2. Therefore, our answer is B. So again, just to wrap up 45-45-90s, please understand that all we're looking for, if these are 45 degrees here, and this is a 90, the legs will always be the same number, and then the hypotenuse is always a leg times radical 2. All right. The reason that is because we're moving on to another type of special right triangle, and that is a 30, 60, 90. These get a little more difficult because we have it's not quite the same as a 45, 45, 90. In a 30, 60, 90, we can see that across from the smaller angle will be the shorter leg. That'll be x. Across from the larger angle will be x times radical 3, and then the hypotenuse is always twice the shorter leg. So to find the hypotenuse, we would take 2 times the shorter leg. To find the longer leg, we would take the shorter leg times radical 3. If we ever need to find the shorter leg, there are two formulas for shorter leg. Depends on what they give you. If they give you the hypotenuse, it'll be the hypotenuse divided by 2. Or, let's say they don't give us the hypotenuse. Let's say they give us the longer leg. The shorter leg would be equal to the longer leg divided by radical 3. So it's all in what information they give you as to how you can apply it. Okay? All right, so let's take a look. All right, so let's take a look here at example number 4. Okay, so they want us to find the height of this equilateral triangle. So what we are going to focus on is we're going to break this down into one triangle. We're going to break it down into this triangle right here. We have our 30-degree angle here. We have our 60. We have our 90. We are trying to find the height. So we are trying to find the longer of the 2 legs. So if we flash back up here to our longer leg is equal to our shorter leg times radical 3. So let's just write that here, short times radical 3. So we just are going to plug in the information we know. The shorter leg is always across from the 30-degree angle. In this case, it is 3. So we have a 3 times radical 3. We cannot simplify that any further, so we will leave that as 3 radical 3. So the height of the equilateral triangle is 3 radical 3. You would have gotten that had you done the triangle that we did. You would have gotten that had you done the other triangle that is created there. Okay? All right, last but not least, example number 5. Now they're going to ask you to find 2 of the missing lengths, not just one of them. So we need to find across from the 30, and we need to find the hypotenuse. So we need to find the shorter leg and the hypotenuse. Let's flash back up here to what we have in terms of formulas. The hypotenuse is 2 times the shorter leg. Okay, but notice here that we don't have the shorter leg, so we can't find the hypotenuse yet. So we have to find the shorter leg given the longer leg, and that formula is the longer leg divided by radical 3. So write that down here, long divided by radical 3. So we are going to do this one first. So the shorter leg is x. So x is going to be equal to the longer leg divided by radical 3. The longer leg here is 9, and that's divided by radical 3. Now, we've talked about this a little bit. We are not allowed to have radicals in the denominator, so we do what's called rationalizing the denominator. How we do that is we just multiply top and bottom by whatever that radical is in order to get rid of the radical. When we do that, we get radical 3 times radical 3, which, if you remember, is radical 9. The square root of 9 is 3. So that number that's inside comes outside. We have our 2 factors that we need to break out of jail, and we get here. Up top, we will get 9 radical 3. Not quite done with it yet, because hopefully we see that 9 and 3 have a 3 in common. So this would become a 1, this would become a 3. So our final answer to x is 3 radical, it's a horrible radical, 3 radical 3. That is our shorter leg, 3 radical 3. Now from there we can find our hypotenuse. In order to find our hypotenuse, which is y in this case, let's change colors, y is equal to 2 times the shorter leg. So we take 2 times 3 radical 3. Can't mess with anything inside the radical, so we're just going to multiply those two together. So 2 times 3 is 6. 6 times radical 3 would be our final answer. So a lot of information going on with 45-45-90s and 30-60-90s. We will talk a lot about the different formulas. I would like to see you try to memorize these, but I will also give them to you on your quizzes or tests. Bring any questions you have with you to class, and we will see you then.